welcome to your first video lesson following a quiz. This will be a bit of a routine for most of the classes where the time after the quiz will be spent watching a video, learning some new information, so that you don't have to wait for everyone to finish the quiz in order to learn new information. So this gives you a little more freedom to work at your own pace. So you'll get your quiz results next class. If you didn't do well, remember you can always come see one of us 5 geometry teachers, either during lunch sessions on Monday, Tuesday, or Wednesday, or after school Wednesday and Thursday. Check the syllabus to find out who is offering a session when. So remember, Unit 1 is incorporating both Chapters 1 and Chapter 2 of our geometry book. And in Chapter 2, we're going to start with Section 2.2, and then we're going to backtrack to Section 2.1 next class. So you'll do that with your teacher in class. In Section 2.2, it's a lot of review, I hope, of what you learned in Algebra 1, which were the properties. Some of the properties have been eliminated on this notes sheet. That's because we really won't use them. So instead of going through them again, we just decided, you know what, we're not going to include them. So if you see certain properties in the textbook and you wonder why they weren't on this notes sheet, it's because they're probably, or they really aren't going to come up in any of your homework questions or on your assessments. Okay, so let's review our algebra properties. The top part of this table is dealing with only properties of equalities. So when you go through here, you'll notice all of these algebraic and geometric examples have equal signs in them. And then down here, these last 2 properties are properties that can be done with equality or congruence. So we can do congruent symbols or equal signs, but up here you cannot do any congruence, it's only equality. Now I will not require you to name like the transitive property of equality or the transitive property of congruence. I will only have you just write transitive property. Your math teacher might have you do something different. But for me, my students, you don't need to distinguish between the 2. Okay, so let's look at this first example. It says that we're trying to come up with a property name. The description is adding the same thing to both sides of an equation. So we're adding the same thing to both sides of an equation. Looks something like that. This, if we start with x equals 5, that would be what is given. Then we would add 2 to both sides. Well, we added 2 to x. If we add 2, do we get 7? Yes. So we kept that statement true. We just added the same thing to both sides. So we added 2 to both sides. Geometrically, we might say some length AB is equal to 3, length BC is equal to 4. If we added AB plus BC, shouldn't that be true and equal 7? Yes, it should equal 3 plus 4 because AB equals 3, BC equals 4. So therefore, this is a true statement. We call this the addition property. Let's look at the second one. If we're subtracting the same thing to both sides of an equation, well, knowing that we just did adding the same thing to both sides and it was called the addition property, probably subtracting the same thing from both sides is called the subtraction property. You guessed it. So here we have x equals 12. Well, if we subtract 3 from x, then we have to subtract 3 from 12 to get a balanced equation. So that becomes 9. X minus 3 equals 9. If the measure of angle A plus 20 equals 60, then the measure of angle A equals 40. What did we do? We subtracted 40 from both sides. So this is called the subtraction property. Okay, then what happens if we multiply the same thing to both sides? So if we have x divided by 5 equals 6, well, what do we do to both sides? We multiply by 5 to get x equals 30. Or geometrically, if half of AC equals AB, then multiply by 2 on both sides and we get AC equals 2AB. And yes, this is tricky, I know, but it is called the multiplying property. Multiplying property, there you go. Sorry, I crossed my L, didn't mean to. And any guesses on the next one? Dividing the same things on both sides. If 2x equals 4, we divide by 2 on both sides to get x equals 2. If twice the measure of angle A equals 40, then the measure of angle A by itself equals 20. So that is the division property, right? So it is the division property. Next, if two quantities are equal, then you may replace, key word there, you may replace one with the other in an expression or an equation. So if x equals 3 and x plus y equals 7, then that means I can replace the 3 for x, so 3 plus y would equal 7. You have done this many times algebraically. And so here it is geometrically, the measure of angle A equals the measure of angle 1. And the measure of angle 1 plus the measure of angle B equals 90. So therefore, through what property? Through substitution. So because of the substitution property, we can replace one for the other. Property. Sorry. Property. So replacing or substituting, it's a substitution property. Distributive property, everyone seems to remember that. Distribution, what do? You distribute a quantity. What's an example of that? Well, it might be something like this, right? So we distribute 2 times 1 plus 2 times 3, right? So what do we get? Well, that's 2 times 4, which is 8, or that's 2 plus 6, which is 8, the distribution property or distributive property. Now geometrically, would we really do that? Well, you won't really see it in terms of measures of angles and in terms of lengths. You might see it if we put like twice the measure of AB plus CD, but not really. I mean, we would distribute the 2 between there, but you probably won't see us write it out like that. Okay, our final two, remember, can be used for equality or congruence. So this one we will use, once we get to proofs, we will use this quite often. And this is called the reflexive property. Okay, so it is the reflexive property. So let's see what it says. It's like reflecting the same image in the mirror. The reflexive property, sorry, but it reminds me of a reflection. Everything is equal to itself, right? DE equals DE. Yes, that's true. The measure of angle D equals the measure of angle D. Yes, that's true. Segment DE is congruent to segment DE, or angle D is congruent to angle D. Yes, that's called the reflexive property. And finally, our last one is a transfer of equality. An entire side will be replaced. So if DE equals FG and FG equals JK, then what does that mean? It means we can pretty much eliminate FG and just say that DE equals JK. Or in terms of angles, if the measure of angle D equals the measure of angle E and E equals F, then it must be true that D equals F. Same thing works with congruence. This is called the transitive property. You are transferring information. Okay, so what are we going to do with this? Well, again, why are we learning this? Well, we're going to use these when we finally write a proof. These will be our justifications in the proof. However, right now we're not doing formal proofs. We're just trying to get you guys familiar with how to make a conclusion and how to write a justification. So these are not connected right here. 1 is not connected to 2, 2 is not connected to 3. They're just separate problems. So number 1, it says AB, the length of AB equals the length of CD, and BC equals BC. So this was given. You don't have to say, what? I don't get it. It doesn't matter. It was given, right? If we had a segment, AB equals CD. This is what that's saying. So AB equals CD, and then BC equals itself. Yeah. So isn't it true? Let's say this is 1 unit, and this is 1 unit, and this is 3 units in the middle. Isn't it true that AB plus BC equals CD plus BC? Yes, they both equal 4. Well, what did we do? We added AB plus BC, and then CD plus BC. We added them together. So this is true because the addition property. Look at the example on the front. right? The addition property right here, that is this example right here. We took A, B, and B, C and added them together, and that equals the other two added together. So this was given, we told you what the conclusion was. Why can you conclude that? Because of the addition property. Let's look at the second one. If twice the measure of angle 1 equals 72, that's what was given. Then the measure of angle 1 equals 36. That's the conclusion. Well, how did they get from the given to the conclusion? Hopefully you're saying to yourself, they divided on both sides. Well, what do you call that when you divide by something on both sides? That is the division property. Okay, next. The measure of angle A equals 1/2 the measure of angle X, and 1/2 the measure of angle X equals the measure of angle B. Okay, I'm telling you the justification. So if I told you the justification, then you should be able to go back and find the conclusion. Well, I'm telling you the justification is the transitive property. So let's go back and see what the transitive property is. The transitive property is if one thing equals another thing, if D equals E and E equals F, then we can substitute D, then D will equal F. So let's go back and look here. If the measure of angle A equals 1/2 the measure of angle X, and here's 1/2 the measure of angle X is repeated equals the measure of angle B, then what can we do? We can conclude that the measure of angle A equals the measure of angle B. That is the transitive property. We transferred this information. So we replaced the 1/2 measure of angle X and set these equal to each other. Okay, how about number 4? Point B is in the interior of angle AXOY. So here's angle XOY, and point B is on the interior. Okay, well again, I told you the conclusion, or sorry, the justification. The justification is the angle addition postulate. So you have to go back into your Rolodex of what you've learned so far and remember what the angle addition postulate tells us. And the angle addition postulate tells us that the measure of angle XOB plus the measure of angle BOY will equal the measure of angle XOY. Right? So this measure of angle 1 plus the measure of angle 2 equals the measure of angle XOY. We could say the measure of angle 1 plus the measure of angle 2 equals the measure of angle XOY. So this part plus this part equals the whole thing. That's what the angle addition postulate tells us, so we should be able to conclude that from this statement right here. Okay, let's go down below. Here's a diagram this time, and the diagram has marks here and here, so these are congruent to each other, and here, so these are congruent to each other. So RS equals PS, and ST equals SQ. That's just given. So what are we concluding? We're concluding that RS plus ST equals PS plus SQ. Again, key here, plus, we're adding these together. So what is that? That's the addition property. Okay, so now look at this. RS plus ST equals PS plus SQ. That's given. So how can we conclude this information here? Why does RS plus ST equal RT? Or why does PS plus SQ equal PQ? Well, hopefully you're saying that's the segment addition postulate, right? One part of a segment plus another part of a segment equals the entire segment. And then if we took both of these as our given, so now we have this and we have this, RS plus ST equals PS plus SQ, and RS plus ST equals RT, and PS plus SQ equals PQ. Why is this true? Why will these two equal each other? Well, that's because I can substitute this in here, and I can substitute this in here. This equal statement is already true. We just said that these were true. Therefore, we can conclude that RT equals PQ. Why? Because of the substitution property. And we actually just did a proof there, except we didn't call it approved and you didn't really know it. So I combined two steps, these two steps, to get my final conclusion. And that's it. Get started on your homework.